Good morning, ladies. Today we're going to continue the lesson we started with yesterday, which is families of functions. Okay, so a quick summary here for yesterday's lesson. There are a set of functions called families in which each function is a transformation of a special function called the parent function. We said the parent function is y equals x. And whatever adding numbers, multiplying numbers, subtracting whatever numbers next to the x here, it means we're having a transformation. Yesterday we took two types of transformation, the translation, which we had two types of translation, vertical and horizontal, and we also took the reflection. Now, today we're going to continue with the vertical stretch and compression. Okay, so now let's start with this idea. Stretching and compressing a function. Okay, a vertical stretch, multiply all y values, because it's vertical stretch, so we're going to multiply all y values of a function by the same factor greater than 1. So we're going to multiply f of x, all of it, with a factor which is greater than 1. A vertical compression reduces, because it's compression, so it reduces all y values of a function by the same factor between 0 and 1. So now we're having vertical compression and vertical stretch. Also, let's put in mind that the stretch and the compression, they're always vertical, so we're only going to change for y. We're going to multiply a by y, okay? Which is f of x. So if we multiplied a number here, let's say a, okay, with f of y, it will be vertical stretch is going to happen as a vertical stretch or a vertical compression. How do we differentiate? We said if a was greater than 1, it's going to be a vertical stretch. We're stretching it because it's greater than 1, so we're going to stretch it. If a was between 0 and 1, between 0 and 1, like 0.5, 0.3, 0.2, it will be a vertical compression. So the vertical stretch is going to be greater than 1. The a over here is going to be greater than 1. And if it was vertical compression, the a is going to be between 0 and 1. Okay, so now let's start with the first example we have, which is stretching and compressing a function. Okay, the table below represents the function f of x. What are corresponding values of g of x and possible graphs of g of x for the transformation g of x equals 3f of x? Okay, so let's solve it together here. Let me just have, okay. So here, from f of x, it's going to be g equals 3f of x. So we have a factor here, or a number that's multiplied by y values. 3. Now 3, is it greater than, or is 3 greater than 1 or between 0 and 1? It's greater than 1, right? So it means we're going to have a vertical stretch or a vertical compression, because 3 is greater than 1, so we're going to have a vertical stretch. So here we're stretching, okay. So here we're stretching because a, or the number or the value, we're multiplying it by the y values here, or f of x, is greater than 1. Okay, so here's f of x and here's x. This is given for us. Okay, let's find 3f of x, which is g of x. So we're going to multiply -5 times 2. Oh, sorry, the f of x itself, we're going to multiply it by 3. So all values of f of x, we're going to multiply them by 3. So the answer of g of x is going to be 3f of x. Now this is the original graph we have. After multiplying it by 3, we stretched it into this graph. Okay, so this is how we stretch it vertically. Vertical stretch we're having here. Okay, so now let's go for the second example we have here. The table below represents the function f of x. What are corresponding values of h of x and possible graphs of h of x for the transformation h of x equals 1 over 3 f of x? Okay, so we're going to look at the factor, or the number that we multiplied it by f of x here, which is 1 over 3. Now 1 over 3, is it greater than 1 or between 0 and 1? So f of I mean 1 over 3 is going to be between 0. So it's going to be between 0 and 1. It means we're going to have a vertical stretch or a vertical compression. It's less than 1. So it's going to be vertical compression. I'm going to write COMP as compression because I won't write the whole word here. So we're going to have a vertical compression. Now this is the table for x and f of x. And they're asking for h of x, which is 1 over 3 h of x. So each value here from f of x, we're going to multiply it by 1 over 3 to find the answer of h of x. So again, this is the original graph we're having, which is f of x. After multiplying it by 1 over 3, we had a vertical compression here. Do you see how the numbers decreased here? The y values here, they're decreased. The y values here, they're decreased. The y values. Can you see h of x? So h of x values, they decreased, so we're going to have a vertical compression. So this is the difference between the vertical stretch and the vertical compression. Now, the second idea we're having in our lesson today, which is combining the transformations. So we have different transformations. We said we're having the translation, vertical translation and horizontal translation. We also have reflection, and we also have vertical stretch and vertical compression. So here we're having 3 types of transformation, and we're going to combine these transformations to see how many transformations do we have in one equation here. Okay, so now let's read the example here. The graph of g of x is the graph of f of x equals 4x compressed vertically by a factor of 1 over 2 and then reflected in the y-axis. What is the function rule for g of x? Okay, so let's solve it together. Okay, so here let's read what do they want in this question. Okay, so here we said that the graph of g of x is the graph of f of x. This is the equation we have. G of x equals f of x compressed vertically by the factor 1 over 2 and then reflected in the y-axis. So first of all, f of x, we have f of x equals 4x. Now they're asking for compression. We are asking for compression by 1 over 2. And they're asking with reflection in the y-axis. So the reflection in the y-axis, it means we're going to change the values of x, or the sign of x, right? So it's going to be as y, or like f of negative x instead of f of x, right? Because we're changing the values of x itself. So let's start with step by step. Let's first start with the compression here. So with the compression, we're going to multiply f of x by half. So it's going to be 1 over 2 multiplied by 4x. So half times 4, which is 2x. So we're done with the first thing here, which is compressed vertically by factor 1 over 2. We're done with this. And then reflected in the y-axis. So this we have to reflect it in the y-axis. So it's going to be as g of x, it's going like f of negative x. So we're going to change, it's going to be 2 negative x, which is equal to negative 2x. It means after all, g of x equals negative 2x. This is the final answer. Okay, so we started one by one. Now let's check our answer together. So here it's going to be, first of all, they started with the compression here. Half times 4x, so this is the first step we did. Yes, that's right. Reflect the new function in the y-axis. So we're going to reflect the x itself. We're going to change its sign. So it's going to be negative 2x. The function rule g of x equals negative 2x, which is correct. Okay, let's go for the second problem we're having here. What transformation changed the graph of f of x to the graph of g of x? So they're giving us this, and they're asked us what is the transformation. Okay, so let's solve it together. Okay, so let's try this together. So we have to find what What are the transformations that happened here? So first of all, we're going to just substitute 2x here instead of x squared here, okay? Or like instead of 6x squared, it's gonna be like 2x squared. Let's see it here. It's gonna be like 2x squared originally. Now, what times 2 would give me 6 here? 3. Times 2 would give me 6. And we have outside -1, right? So now we're going to look at this. What happened to 2x squared? So it would change to 6x. We multiplied it by 3. So first of all, what happened here? We multiplied it by 3. So we have here a vertical, what? 3 is greater than or smaller than 1. 3 is greater than 1. So it's going to be vertical stretch. We have the vertical stretch by a factor of 3. This is the first thing we have. The second thing we had here is subtracting 1. So here the subtraction is outside the bracket, so it's going to be transformation, a vertical or horizontal transformation, because the adding or subtracting here that we have is outside the bracket, so it's going to be vertical transformation. Because it's negative, it's going to be vertical transformation 1 unit down. So again, vertical transformation, or let's say translation, one unit down, right? We just put here, instead of like 6x squared, originally we had 2x squared. We wanted to change it to 6x squared, so we multiplied it by 3. Then we had one thing outside here, the brackets, which is -1, so we just added -1 here. So this is the origin, and after multiplying it by 3, we had a vertical stretch, then we had a translation 1 unit down. Let's check our answer. So let's check here. Originally we had f of x, then we multiplied it by 3, then -1, as I said. The graph of g of x is the graph of f of x stretched vertically by the factor of 3, yes, as we said, then translated down 1 unit. That's right, that's as we said. So this is the first thing we had, which is stretched vertically. Then we had translated down 1 unit. Okay, let's see the last problem we have in this lesson. Okay, the graph g of x is the graph f of x equals x stretched vertically by a factor of 2 and then translated down 3 units. What is the function rule of g of x? Okay, so let's solve it together. Okay. So f of x equals x. So first of all, we have f of x equals x stretched vertically by a factor of 2. So stretched vertically by a factor of 2, we're going to multiply f of x by 2. So it's going to be 2 multiplied by f of x, which is 2x, 2 times x. This is the first thing we're having. Now after this, we're having then translated down 3 units. So it's going to be as f of x, 2f of x actually, we have 2f of x, translated 3 units down, subtracted by 3. So the final answer we're having for g of x equals 2x minus 3. Let's check our answer. It's going to be here f of x. We multiplied it 2 by f of x, the first thing. Then we subtracted by 3. So this is number 1 and this is number 2. So g of x totally equals 2x minus 3 as we got, which is correct. So now we're done with this lesson. Let's have a quick summary for the whole lesson. We had the vertical translation. It means the translation up k units we're going to add by k outside the brackets, and down we're going to subtract by k. For a horizontal translation, the translation right, you're going to subtract k, subtract h inside the brackets, and when you translate left, you're going to add h inside the brackets. Now vertical stretching and vertical compressing. A vertical stretch, when you multiply f of x by a and a will be greater than 1. That's for the vertical stretch. Where's the mouse? Yes. And the vertical compression here, when you multiply a by f of x, where a is going to be equal to a number which is between 0 and 1. Now the last thing we had here, which is reflection. When you reflect about the x-axis, it means that the y values will be the negative sign, so you're going to subtract f of x, all of it. And when the reflection is in the y-axis, it means the x values will be the opposite sign, so you're going to subtract the x here inside the brackets. Okay, so that's it, girls, for this lesson, and have a nice day.